Sprint planning. Sprint planning is a ceremony that is typically done at the beginning of the sprint on day 1. There are some teams that may do it on the last day of a previous sprint. So what does go into the sprint planning? The inputs are product backlog, bugs, and spikes. Keep in mind that bugs and spikes are part of product backlog technically. I have separated them out so that you don't miss it. So what happens in sprint planning? We have capacity planning both at individual level and team level. We have story prioritization by the product owner. The team does estimation both for stories and underlying tasks. So what is the output of sprint planning? A sprint backlog. A sprint backlog is a subset of product backlog. The stories in the sprint backlog are the stories that the team are committing to deliver at the end of the sprint. Capacity planning. So how do we calculate capacity for a team? It's simple. Team capacity equals number of team members into hours per day into number of days. Before we look at an example, let's go into details. So what do we consider in capacity planning? Utilization of every team member in terms of percentage per day, leaves of individuals and holidays across teams, the total number of sprint days depending on the sprint size, meetings and any other ad hoc work, and any capacity for support from the team members. Now, let's look at an example. Here is an example capacity planning sheet in Microsoft Excel. Now keep in mind that the same functionality can be achieved using any modern tool like Azure DevOps or Jira. If you look at the sheet, on the left hand side we have the team members. We have total of 8 team members, out of which we have a technical lead, we have 4 developers, 1 user experience and 2 QA. If we look at their utilization, developers are 100% utilized, the QA are 75% utilized, whereas the technical lead and user experience or shared resources, they are 50% utilized. If you go to the right hand part of the sheet, the total number of days for the sprint is 10. This is a typical 2-week sprint. There are 2 holidays coming up in the upcoming sprint. And there are a total of 10 hours being spent per team member on the team meetings. And the working capacity per team member is 8 hours per day. If we come back to the sheet, you can see that there are 2 team members who are taking leaves. Tina is taking 2 leaves in the upcoming sprint, and Ramesh is taking 1 day in the upcoming sprint. Now, effectively, if we subtract the leaves and holidays, this is the availability of the team members. Look at Tina, she has availability of 6 days, and Ramesh 7 days. If we convert the days into hours, this is what it looks like. As mentioned earlier, we are considering 10 hours of meetings per team member. We are reserving capacity for bug fixing across the team. We have allotted a 10% bug fix capacity. If we subtract the meeting hours and the bug capacity, this is the final capacity of every individual team members. This is in hours. Now, the last column is the actual estimation of hours in Jira. The tasks are created underneath stories, and these are the hours against every developer and QA. So the ones in the red means that the resource is overloaded. He has a capacity of 47.6 hours, whereas he has estimated his task to be 52 hours. Likewise, for Narendra, he has a capacity of 18.8 hours and he has estimated his task to be 20 hours. Now, the Scrum Master would have to look at available capacity for the rest of the team members and move the tasks underneath them. The total capacity of the entire team is 274 hours, whereas their estimations are 264 hours. The additional 10 hours can be used to pick up an additional task or a story. Story point estimation. Story points are typically used to estimate any user story. So what are the characteristics of story point estimation? Story points rate the relative effort of work in a Fibonacci format. The points are estimated based on difficulty of work rather than time needed. Keep in mind that there is a common misconception in the industry that story points are directly proportional to the number of hours required to get the work done, which is not the case. Everyone's perspective are highlighted, particularly when we use a tool like Planning Poker. Planning Poker is the most commonly used tool to estimate story points in a Scrum team. As mentioned, story points are estimated in Fibonacci format. Keep in mind that every team tries to split the stories as the estimate gets higher. For example, a Scrum team may have a threshold of 8 story points. If a story is estimated to be 13 story points, it is split into 2 stories functionally, one carrying 8 story points, the other carrying 5 story points. Story points are reference-based estimation, also known as relative estimation. How is that done? Let's consider 4 stories that we are trying to estimate. The ideal way would be to identify the story that is least complex. In this case, it is story 3. We assign 1 story point to that particular story. From this point on, we compare the story 3 with every story in terms of complexity and then estimate the respective story in terms of multiples of story 3. For example, story 1 we have estimated 2 because it's double the complexity of story 3. Likewise for story 2, it is 5 times more complex than story 3. And for story 4, it is 3 times more complex than story 3. Velocity. Velocity is the sum of story points taken or delivered in a sprint. Average velocity is the average of velocities for the last 3 to 4 sprints. We'll look at an example in the upcoming slide. This average is used for identifying over or under load in upcoming sprints. Keep in mind that velocity differs from team to team. Here's an example. Let's consider a team which was able to deliver 11 story points in sprint 1. In sprint 2, they have delivered 13 story points. And in sprint 3, they have delivered 15 story points. Now, if I have to calculate the average velocity, it comes to 13. I would use this information to forecast for upcoming sprints. If I am trying to fit in 16 story points in sprint 4, I'll be overloaded. If I try to fit in 13 story points for sprint 5, I'll be assigning the correct load. And for sprint 6, if it is 9 story points, I'll be underloaded. For my forecasting and estimation, I can move around stories across sprints so that I am within the capacity of the team. Now, as promised, we will revisit release planning here with respect to story points. It's the same product backlog that we discussed. We have 3-month timeline and we are planning for 3 sprints. Now, all the stories in the feature are marked with their respective story points. Now that I know the velocity for every team, I can plan the stories accordingly. Team 1 has a velocity of 10. As you can see, in sprint 1 they have 9 story points, in sprint 2 they have 10 story points, and in sprint 3 they have 10 story points. For team 2 with a velocity of 9, sprint 1 they have 11 story points, they are overloaded. Sprint 2 they have 10 story points, they are overloaded. And in sprint 3 they have 10 story points, they are slightly overloaded. And for team 3 with 12 as velocity, sprint 1 they have 13 story points, sprint 2 they have 11 story points, and sprint 3 they have 11 story points. For teams that are overloaded in sprints, they can go with MVP stories and underload themselves.